the record button at the end. Just hit it again. All right. When's the homework due? Monday, start of class. That's right. How do you turn in the homework? Physical paper, staple in the upper corner. And by staple I mean that metal thing that connects the papers, right? Like, not some kind of like paper folding, multi-paper kind of. Every so often I get people trying to make staples from paper and some sort of origami in the corner, and like, no, I need a staple, not a paper clip, like a staple. So listen. So this is mission 1 I have in front of me here. I wanted to, before I forget, look at mission 2 for a second with you. Now mission 2 is due when? Yeah, the 4th, which is pretty soon too, right? And my apologies for these getting bunched up so much. It's just because I've gotten a slow start this semester. But on the flip side of thing, I didn't give you work the first week, right? So I would usually have work due the first week as a, just to keep things going. But anyway, so there's some inequality. Mission 2 is mostly on inequalities, right? But I wanted to point out something here while we're together. And I started talking about how to solve these inequalities last time, right? But I'll do more of those today, hopefully. And I'll also talk about how to graph inequalities. Oh, you're fine. Oh, sorry about that. Just furniture though, right? Like we're not like people. Oh. Are the people broken, or is it just just the stuff? Okay. And there's some questions about parallelograms and distances, and we'll talk more about that stuff next week. But hopefully today I'll also introduce circles and lines. You may have seen these before, probably have, but talk about how to how to graph circles and lines. But the other thing that's in this homework is there are some things which require a graphing calculator or a web resource, right? So if you have a graphing calculator, great. I don't expect you to have a graphing calculator for the exam. So like problem 18 isn't something I would actually have on your test. But I do think it's important for you to do this because we should know how to find numerical solutions to things, right? So it's part of the homework, but it's not part of the test. On the test, I would have to do something like provide the plot for you and ask a question about it. That's how it works for me. But in the homework, I will ask you some like numerical stuff, right? Like this one. Sketch the result by hand and include any explicit labels for x or y intercepts. You notice this click here for an answer? So you do want to look at this electronically. I mean, you need to print it out because I want you to write your solutions on these pages, all right? But if you click that, it'll load up what's called Desmos, www.desmos.com, which is a free open source graphing utility, which is super nice, super useful. And it also has, the really cool thing about it, by the way, among other things, is you can actually share your graph with like collaborators. Like if you make a graph and you want to say, hey, look at my graph, and you're not in the same room as somebody else, you can send them a link to your graph and they can look at it. It can do all kinds of stuff, though. This is just an example. What does x-intercept mean? That's where it intercepts the x-axis, right? So how would you find that out here? You just basically zoom in and try to see where that is, right? Zoom in is up here. So you can kind of, and I think I asked for answers to 2 decimal places. So I mean, I'm not, do your best, don't spend an hour trying to get it down to 5 decimal places or something silly. So this is one thing, this is Desmos, all right? So I've got a couple links. You should click on those links in the homework, all right? Now, let me just do a new one. Just want to show you some things like, today we're going to talk about equations of lines, right? So let me just make it easy on myself here. Y equals mx x. And see, one of the really neat things about Desmos that your graphing calculator, as far as I know, can't do without a lot of trouble, is it can add sliders. So I can add a slider for B and a slider for M, and what that does is it allows me to change, like here. If I change the y-intercept, what does it do? Changing B up makes the line go up. Make it negative, it makes the line go down. It changes where the y-intercept is, right? The slope, that's the coefficient of M. If I want to change that, it'll make the line, the bigger it is, the steeper the line. When you get negative, it points the other way, right? And you can even, if I could get rid of these dumb smartboard things that are in the way of everything. There we go. Check this out. See, you can even animate, and look what happens as you change different parameters as you go around. You can even make them do both at once. I don't know what this would really aid your understanding of pre-calculus, but it's fun to look at, right? So there you go. The other thing we'll look at today would be, so this is the what? This is the point slope form. You could also do like, let's see here, what's the other form? Slope point would be another one. So I could use, here I'll get rid of the other ones. So this is so-called, oh, oops. So what's this do? This gives you a line that has slope m. Can you guys read that? I don't know if you can or not. This gives you a line that has slope m, and it goes through the point h comma k. So if you got like a point and you got a slope, you can write this formula down. You immediately have a line that has that point and that slope, which is super nice to know. And again, you can do this. As you move h and k around, what's it do? It's going to move the point. It's kind of hard to see that here, but I don't think that's especially interesting. Let me stop talking about lines. The other thing we'll look at today will be circles. All right? So what's the equation of a circle look like? You guys already know. X squared, I think you already know, plus y squared equals to what? R squared. And we'll add a slider, R. Now, I don't usually think of R being negative, so I might change this to be 0 to 10, and then you can make the steps whatever you want, like maybe 0.1, for example. And if you animate it, there you go. We have circles of radius 0 all the way out to radius 10, and that's the graph of them, right? So how would you make the circle go somewhere else? Like what happens if I add, say, plus m, may not use m, let's say I'll use big B. I'll use 2b, 2bx. So what happened to the circle as I change b? See what it does? It moves the center of the circle from where it is to somewhere else, right? So basically, in fact, if you look at it, the center of the circle will be the value of my b. Well, minus the value of my b. If I put a minus here, I think it'll actually be at b for what it's worth. Let's see here. If I go to 1, yep, see the circle centered at 1, circle centered at 2, circle centered at 5, right? So if we include an x term, it shifts the circle left or right. If I was to, say, do the same but with y, like that, what do you think is going to happen? It's going to go up and down, right? Now, the reason the circle is getting bigger and smaller has to do with the algebra of completing the square, which we'll look at. But so now that you've seen some circles and some lines, let me just go ahead and write down the standard form on the chalkboard, and then I'll go back to the homework questions you guys have. Let me just try to keep it in order here so that we make the most of today. Otherwise, I'll end up reinventing the wheel when I come back to this material later. So this is like, I was watching the video again. I'm like, oh, that's really annoying. Look like I'm always about to like choke myself or something. So line. So you've got point slope form. So if the point that you want on the line is, say, x1, y1, and the slope is m, then what you can use is you can use y equals y1 plus m times x minus x1. What that's going to do is give you a line that has the point x1, y1 on the line, and it has slope m. For example, if I wrote down y is equal to 3 plus 7 times x minus 2, I can tell you, I can see that the point 2, 3 is on line, and the slope m is what? 7, right? If you want to, I could graph it. So it's got this point, right, 2, 3, and it's got a slope of 7, which means every one it goes over, it goes 7 up, right? Remember, slope is rise over run. So, oh, goodness gracious. 1, 2, 3, 4, 5, 6. I should have picked a smaller slope. Good grief. This thing's really steep. Something like that. So this is point slope form of a line. What's the other typical formula we use for a line? What? Slope, intercept. There's at least like 2 other common ways to talk about a line, and I'll let you look at those in the homework. They're not especially interesting, but they're worth reading the section. But I'm just going to focus on the 2 big ones here in class. Slope intercept. So we usually use m for slope, usually use b for the intercept, and that's this one, y equals to mx plus b. Right? So for example, you're given y is equal to 3x plus 2. I can tell you, as soon as I look at that line has slope 3, and it has a y-intercept of 2, right? And so I could use that to graph the line. So it goes through the y-axis at 2, and remember this m is always what? It's like rise over run, right? You can also look at that as change in y over change in x. Right? If you have 2 points on the line, we can write the slope in terms of the difference of the ratios of the y and the x components, respectively. So like y2 minus y1 over x2 minus x1. That's how you calculate the slope. If you have 2 points on the line, you can find the slope from that ratio, right? Going back to my example, so we go over 3. We go up for every 1, we go over, we go up 3, right? So I'm like up to here. If I go back, I got to go down 3 for going left 1. So to the limits of my artistry, the line looks something like that, right? Does anyone know any other popular, formulations for the line? Sometimes we also tell you guys like the 2-point formula for a line, right? But I don't usually try to remember that. I just try to work it out. So I'll do one more example, then I'll stop talking about lines. What if you gave me 2 points and I wanted to find the equation of the line through those 2 points? How would you approach it? Let's have some classroom interaction. What point would you like? 0.3 is the x-coordinate. I will take a y-coordinate. What? 7, 3, 7, and 2, 1 are on a line. Find the equation of the line. Now, if we had memorized the 2-point formula for the line, this question is really, really simple. You just plug it into that 2-point formula and you're done. But what I'm going to do is I'm going to use the thing I just erased. Well, no. Well, yeah. Well, first of all, I'm going to find the slope. What's the slope? 6. I agree with you, but why is that? 7 minus 1 over 2 minus 3, right? Wait a minute. 3 minus 1. I'm an idiot. 3 minus 2. I'll get it eventually. So I'm calling. So I'm saying 2, 1 is like x1, y1, and I'm thinking of 3, 7 being the x2, y2, just for the sake of, So the difference, so y2 minus y1, 7 minus 1, and then x2 minus x1, that's 3 minus 2. What's the question? Y2 is equal to 1? Well, x1 is... You could go either way. I mean, I was following the slope that somebody said in here, so that forced me to label the 2, 1 as the x1, y1 point. You're thinking the other way around. It actually doesn't matter. As long as you make your choice and stick with it, you'll find the same formulas in the end. If we did what you were thinking, that would just give us 1 minus 7 and 2 minus 3. So we'd still get the slope being 6, but it would have been because 2 minuses cancel. Anyway, the slope for this line is definitely 6. And then what can I do? Pick whichever point you like. I'll use this one. 1 plus 6 times x minus 2 . There you go. That's the equation of the line that we're looking for. Now, that might not have been an acceptable answer in a previous course you had, right? Because it might have been that you had an instructor who wanted you to give the answer in what? Y equals mx plus b, the slope-intercept form, right? So how do we get that? It's not a big deal. We just multiply it out, right? So 1 minus 2 is minus 1 plus 6x. So, but to my taste, these are the same answer. Unless I have further instructions on the problem to try to pin you down to give your answer a certain way, Okay? All right, so let's talk about circles. Now, if this wasn't enough, and you need more examples about lines, by all means, ask about them later, right? And you can ask in office hours, you can send me an email. I mean, you have many options. Just ask. We do circles here. So, aw, man. Oh well, it had a good life. So if we have x minus h quantity squared plus y minus k, again, no, quantity squared equal to r squared. If you think about what this means in terms of the distance formula, what it is the set of points. The solution to this is going to be the set of points that are distance r away from a center point h comma k. So like, in other words, this is a circle. Here I'm assuming r is greater than 0 for, for specificity. Right? This is a circle with radius r that's centered at h comma k. So now, sometimes it takes a little work to see that the equation that you're given is actually a circle. Sometimes it doesn't, right? Let me start us with a super easy example. I'm going to write down an equation, and I just want you to tell me where is that, is it a circle, and where is it centered? What's its radius, all right? So I'll answer the first question. Yeah, it's a circle. You guys tell me, where is this circle centered? 2 minus 1. And what else can you tell me? What's the radius? It's not 10. We've got to use our imagination, right? This is square root of 10 squared, right? So to match this pattern, we need square root of 10. Square root of 10. There you go. Right? Is this a problem on the test? Probably, right? Something like it. Is it worth a lot? Probably not. But how long should this problem take you? Yeah, 3 seconds is a good answer. As long as it takes you to read it, right? Now, let me show you another problem, which is going to take a little bit more work. So suppose you've got x squared minus 6x plus y squared plus 10y rather, equal to 0. Is this a circle? You're like, yeah, yes, because of the conversation we're having right now, right? So it must be, otherwise it would be kind of a stupid thing to put on the board, right? But yeah, it is. But how can we? It doesn't have the standard form, right? This is right here below is the so-called standard form for a circle. Right. So how can we make that into standard form? What do we need to do? Say again? Multiply out the squares. I think that's the right thing to do. Let me give meaning to what you mean. We should try to make it look like the standard form, right? We should try to group the variables into a squared quantity, right? So for x, if I do x, and I want to also pick up this 6, what do I have to do? When I square this out, if I have plus a constant, minus a constant here, what do I need to make that constant in order to get back minus 6x when I multiply it out? For example, if I said x plus 4 quantity squared, what happens? Right? So if I were to add 4 here, it wouldn't be smart, because I wouldn't get back this 6x that I had to start with, right? Negative 3, we have a winner. What is this? What's this? What are we doing? This is completing the square. You take half of the coefficient of the x term and add it to x, square that. That will recover the x squared that you have to start with, as well as the linear term that you're trying to group with it. Why are we grouping it? Again, it's so we can match up with the standard form of the circle here. In our previous work, we were completing the square because it allows us to see how to solve it by taking square roots of the equation, you know? Anyway, so yeah, x minus 3 squared. Now, what have I done when I do that? I've just added 9, right? Is there 9? I mean, there's no 9 here, right? So I have to be fair, I have to subtract 9. Now that I've done that, what I've just written here is exactly the same as what's right here. Now what do I do for y? Parentheses y times what? Y plus what? Y plus 5. Now, for those of you who don't understand why she said 5, can somebody? It's half a 10, right? That's where that's coming from. We square that, right? In so doing, we've done what? We've added 25. So we have to subtract 25 to maintain what we had before, right? So when we're manipulating an equation, we kind of, I mean, more or less we have two options, right? Multiply by 1 or add 0, right? So we've added 0 twice in a sense, right? Because writing this adds 9, but then we subtract 9. That's adding 0. We're like adding and subtracting 9. Here we're adding and subtracting 25, if you get into it. Anyway, and then one more step, and we're done. Well, we're almost done. We still have one final step, which is just interpretation, right? So what's 25 plus 9? 34. Okay, so we have a circle. Centered where? I heard 3 minus 5. I like it. With radius what? Square root of 34? Yeah. There you go. If you understand these two examples, you probably should be able to do all the other ones I have assigned you in terms of circles. So you need to learn how to complete the square is what I'm trying to get at. But it's not bad. Okay, what happens if we put a 2 here? Oh, yeah. So you see what happened when I put a 2 there? What did it become? A what? An ellipse, right? Let's see here. Let's try something a little bit more adventurous. And then I'll put this away. What if I had x squared plus a xy What do you think is going to happen as we change a? Look at that. And what else can you say about this ellipse? What does it look like? Notice it's like sideways. And see the other one? See it go sideways? And then it becomes a hyperbola. And then when we go to the other way, it becomes a circle. Then it becomes an ellipse tilted the other way, and it eventually become a hyperbola like the other way. But the axis of symmetry for the ellipse and the hyperbola they're not the x and y axis, are they? They're like tilted lines. We won't even cover this in this course, but I'm bringing it to your attention because I think it's interesting. Why don't we look at equations that have like x, y in the middle? Why do we just look at x squared and y squared like we did? It's because if you include an x, y term in here, it tilts things, right? So if you're actually working like real-world problems, you need to learn this, right? Because you can't hope that everything lines up nice and pretty with vertical and horizontal, right? If you want to do the math of tilted things, you have to learn how to deal with terms like x, y. And that's something we learn in something called linear algebra. So anyway, advertisement for math major done. I will go on. You had questions about the mission. Let's get to those. Wait a minute. You had questions?
Yeah, I have one too, so it doesn't matter.
You all have questions about the mission, it's safe to say. Let's see here. Mission 1, which one?
8E.
8E. So was my video for problem 2 helpful? Somebody in the other section had asked about that. So you may not have noticed or not, I made like a 10-minute video with 2 examples done really slow and, what's that? Oh yeah, you're not required to look at it. I'm saying it will help you with problem 2 if you have doubts. 8, lost the ability to speak again. 8 what?
8E.
Man, there's so many different parts. A monster wrote this, 8E. So what am I supposed to do? At 2x squared plus 8x plus 10. And for each quadratic polynomial given below, complete the square and find all the real or complex solutions of f of x equal to 0. All right. So apparently we're supposed to complete the square on this polynomial. And so let me work a similar but different problem as to not deprive you of the joy of doing your homework. Suppose we had f of x equals to 3x squared. Plus 18x. Hopefully this will work. We'll find out soon. Here's a similar problem. Hopefully similar. How do you complete the square on this? Now, this is, I keep completing the square on things that have what? The what? Greatest common factor.
Coefficient of 1.
Yeah, coefficient of 1, right? They're like the leading coefficient is 1. What do you do when the leading coefficient isn't 1? You make it 1. How do you do that? Yeah, pull the 3 out. Now, I made this easy for the purpose of in class. It could be that you end up with a fraction, right? That won't happen in that problem, like because you can pull a 2 out of that one, right? But you could get fractions here generally. But anyway, here it is, x squared plus 6x plus 4, right? And then we just do what we usually do, complete the square. But we have to do it inside the parentheses, right? So like this is x plus 3 quantity squared. I've just done what? I've just added 9. So I must subtract 9. And we've got plus 4. Okay, at this point, I see I have made a mistake, guys. You'll forgive me. I'm going to change that 12 to a 36. I hope you can forgive me. But I want to make it like the homework problem. I think if I do that, it's the same kind of problem as the homework problem. So factor 3 out of 36, we got what? 12. So I got minus 9 plus 12, right? So I have 3 times x plus 3 quantity squared plus 3. So what can you, after we've completed the square, what can you tell me about this quadratic? Like, what kind of solutions is it going to have? Yeah, complex, right? It's not going to have real solutions, because if you look at this, if you set this equal to 0, well, there's no way you can solve it. There's no way you can get something squared plus a positive number equals to 0, right? So it has complex solutions. And so to find the complex solutions, if I set this equal to 0, what can I do? I can divide the 3 away, right? 3's gone. And then I get x plus 3 squared equals to minus 3. Right? And then if I take the square root of both sides, I get plus or minus the square root of minus 3, which is also known as plus or minus I times the square root of 3. Because, like, square root of minus 3 we can look at as square root of minus 1 times the square root of minus 3, or square root of 3, rather. Fine, one more step. Minus 1 times 3, square root of minus 1 times the square root of 3, which is I times the square root of 3. This is my logic, okay? And so what are the complex solutions? Actually, am I following directions? Did it ask me to find real solutions or complex solutions? What? Oh, either? Okay. So x equals to minus 3 plus or minus I times root 3. And there you go. That would be the solution to my similar but different problem. Let's try to do one that's kind of like one of the harder inequality problem. Well, no, wait a minute. Mission 1. Let's focus on mission 1. My bad.
Can we look at the last problem?
Sure.
I have a question on that one too. So say like,
Which one? Which one?
just like in general, the one we just did.
Oh.
If that 3 would have been like a 9, would you have made it negative 3 plus or minus 3i? If you would have had square root of 9, hypothetically.
Yes. Yeah. So like generically speaking, if you've got x minus alpha squared plus beta squared is equal to times some constant out front, a, if that's your f of x, then what's going to happen is you're going to get x is equal to alpha plus or minus I beta as solution. Generically speaking. You can always, if you've got like a sum of numbers, you can always relook at it as x minus alpha plus beta squared. In the case the discriminant is positive, you can always look at it as x minus alpha minus beta squared, in which case the solution is, I mean, that's the pattern. When there's a minus from completing the square, you get plus or minus that term when you work it out.
I can take a picture of that.
Oh, of course, you can always take a picture of everything in here. I mean, I am all the time. Thanks for asking, though. That is wise. There do exist professors who are like offended if you take a picture and don't ask. Like I'm not one of those people. But, except in real life, I hate when people take my picture. I mean, this isn't real life. As I've said before, you guys are sitting and listening to me talk about math for longer than like 2 minutes without leaving the room. So we're clearly in an altered state, right? Oh, okay. So what was the last problem? Yeah. Is that right? The last problem?
Yes.
Oh, this one. Ah, sure. So the question really is, how do you do complex arithmetic, right? And the answer is just like you do regular arithmetic, just keep it, you know, the basic thing is, like usual, except I squared equals to minus 1. Okay, so here's an example. 3 plus 2i squared. What would that mean? It has the usual meaning. It just means you multiply the thing by itself twice, right? And how do you multiply complex numbers? Like usual, just distribute. So 3 times 3 is 9, and then I get, plus 6i, plus 6i, plus 4i squared, right? And then you can collect terms. The 4i squared is actually what? Minus 4, right? So since I squared is minus 1, this thing right here is really minus 4. So 9 minus 4 is 5. So we get 5 plus 12i. Now, where it gets trickier is like, suppose you're given a complex expression and you're asked to put it into its Cartesian form. Right? There is where you get into some of like the tricks. So put 1 over 3 plus 2i into a plus ib form. This is a different example. This is the so-called Cartesian form. So how do you do that? Well, there's a trick, all right? What you do, I told you earlier, we either multiply by 1 or we add 0. This is one of those places where we're going to multiply by 1. So all you do is you multiply by the conjugate of the denominator over the conjugate of the denominator. I don't think this even is relevant to your homework. I'm just showing you because it's something that's good to know. And I have some residual guilt for not including it in your homework. But anyway, it was intentional that I didn't put it in there.
I think when you work the one out, I think it ends up like something like this.
Oh, yeah?
You're gonna have to do.
Oh, really? Oh, yes, I'm wrong. Thank you, I'm wrong. In fact, you're right. When you actually work this out, you do get back to this problem. You're right. If I could just remember what I did 3 days ago. Let's see here. So 9. And then we get plus 6i, right? Minus 6i. And minus 4i squared, right? So the magical thing about multiplying by the conjugate over the conjugate is it makes the denominator become a real number. Because like it's a generic truth, if you take z times z bar, here z is like x plus iy. The complex conjugate of z is z bar, sometimes denoted z star, stars and bars, I don't know, whatever. I think your book uses bar. So if you look at the product of z bar, what happens? You just get x squared plus y squared. So the product of a complex number and its conjugate is always real. So this strategy of multiplying by the conjugate will force the denominator to become real. And in fact, it's just going to be equal to like the squares of the real and the imaginary part. So like 3 squared is 9, 2 squared is 4. We get a 13 over here. So there you go. And of course, this is also 3 over 13 minus I times 2 over 13. So in other words, my A is 3/13, and my B, the imaginary part, is minus 2/13. for what it's worth. But
So is that in the form, that A plus IB form?
yeah, I mean, the a plus ib is right here. This would also be fine in my book. Like, technically speaking, this isn't quite a plus ib, right? Because you're supposed to write number. Okay, fine. To be really picky, what should I do? I should make that a plus and put the minus in here, right? To make it the pattern a plus I times b, right? To be picky, a plus I times b. That's the pattern. Other questions? See, I'm sad we didn't. Oh, hey, there's still time. Let me at least start solving one that's more complicated here. Oh, you guys have this? Okay. Actually, before I just dive into something, is there another question? I mean, okay. So I started to show you guys how to solve inequalities last time, right? But, you know, and we're pretty well set up if I do something like, say, x minus 1 squared times x squared plus 4x plus 5 times x minus 3 greater than 0. We could solve this, right? How do we do it? Well, here's how I would do it. First of all, I would come to terms with the fact that this cannot be factored, right? What is this actually? That's x plus 2 squared plus what? I'm completing the square, right? So like x plus 2 quantity squared gives me the x squared plus 4x, but it also adds 4, right? I've got a 5, so just 1. I'm just left with 1. So let me just point out what we can see from this, actually. This, never 0, always positive, right? Because it's the sum of a quantity squared plus 1. That quantity squared can never beat the 1. It can at most, it can only add to it. So the smallest that could be is 1. And that would happen when x equals minus 2. This is the kind of thing that completing the square allows us to see. X minus 1, what's the smallest that could be? This right here, this is non-negative. Meaning that it's greater than or equal to 0. So really, the only term here that has hope of being negative is that x minus 3. So I can draw my number line. And if we follow my method, we would put down 1 and what else? 3, right? But do we really, I mean, 1 in some sense is not really needed because we already know what's going to happen. It's going to do what? It's going to go, well, and plug in any points you like, right? How about 4? If we plug in 4, what do we get? Positive, positive, positive. Plus, plus, plus is plus. Now, as we go into the middle between 1 and 3, right, like say 2 as a test point, that's still positive, that's still positive, this is negative. Plus plus minus is minus. So we get, and I already know it's still going to be minus over here because this is the only thing that can change signs. You can put a test point over there if you want, but so what's my solution? Yeah, 3 to infinity. There you go. I just wanted to do one more of these this week before I forgot. We'll do more of these next week. There are ones that require additional algebra in Mission 2. Like it's not already factored, and you got to do some algebra before you can get it in the right form. So I know you guys are still working on Mission 1, so I'll shut up. Have a good weekend, okay? I'm like 3 minutes over, right? 2 minutes over?